Hello everyone, welcome to today's video on finding the area of tilted squares, and then that leads us to the concept of square roots. So a few key things that I have on my starting screen here to know. One is how to find the area of a rectangle and a triangle. So to find the area of a rectangle or a square, you take the base times the height, multiply the side lengths together. To find the area of a triangle, you take 1/2 of the base times the height. And it's important that the height makes a 90-degree angle with the base. Okay, that's what we define the height as. Then when we get into square roots, it's going to be important to know our perfect squares. So that's what I have listed here. 25 is a perfect square. The square root of 25 is 5 because 5 times 5 equals 25. The 64 is a perfect square. The square root of 64 is 8. Because 8 times 8 is 64. All right, so let's dive in. First, we're going to try to find the area of each of these squares below. These are tilted squares, right? So what makes these challenging is we don't know the side lengths. So this takes some challenge, some brain solving, but it's a good challenge for us all. So what I'm going to do is use this decomposition method, where I enclose my tilted square with a non-tilted square, like I just did here, okay? And now I'm gonna first try to find the area of this whole non-tilted square. Okay, so this has a side length. I have 1, 2, 3, 4, 5, and then my base, 1, 2, 3, 4, 5. Okay, so the area of my whole blue shape is base times height, which is 5 times 5. Okay, so that's the area of this whole blue square. Okay, so we know that the area of tilted square A is going to be smaller than 25. So what we can do is we can try to find the area of this space. Okay, so I can find the area of this green and yellow space, and then I can subtract that from my blue to find the area of A. Okay, so how do I find the area of these? Well, these are triangles. So to find the area of a triangle, that's 1/2 base times height. If I take this triangle, it has a base of 4, a height of 1. So the area is 1/2 times my base of 4 times 1. 1/2 times 4 is 2. So this has an area of 2. Okay, with a quick look, I can see that all of these have an area of 2 because I have 1, 4, 1, 4, 1, 4, and they're all triangles. So collectively then, each of these have an area of 2. And I know that the entire enclosed space, including that, had an area of 25. So what I can do then is subtract 25, the area of my whole, minus 8, because this is 2 plus 2 plus 2 plus 2. What is 25 minus 8? That's 17. So the area of square A is 17 square units. Okay, awesome. Okay, so now you can do the same thing. So try square B, try this one yourself. And if you do need help, then you should go back and look, rewatch the example I just did for square A, or look at your notes, or ask me for help, and I would love to help you. So you should have gotten 20 units squared. The area of my enclosed non-tilted square was 36 units squared, 6 times 6. And then the area of each of those outer triangles is 4 because it's 1/2, 4 times 2. So in total, that's 16 units that are not used by square B within the 36 unit big enclosed square. So we do 36 minus 16, and that's 20. So 20 square units. Awesome, okay. So square A is smaller than square B. Square B is smaller than square C. The three square side lengths are the square root of 26, 4.2, and the square root of 11. So using this information, we're trying to fill out this table to the right. Guys, there's a lot going on here. So for each of these squares, given the information we're given, we need to find the side length and the area for that square. So let's first begin with the side lengths. We're given the side lengths, we just don't know which they match with. But we have the square root of 26. Then we have 4.2, and then we have the square root of 11. Okay, so we don't know what the value of the square root of 26 is. 26 is not a perfect square. But if I go back here and I look at 25 and 36, those are both perfect squares. I know that 26 falls in between 25 and 36. So that means that the square root of 25 is in between 5 and 6. Because the square root of 25 is 5, and the square root of 36 is 6. So while we don't know what it is, it's going to be 5 point something. Probably pretty small, since 26 is pretty close to 25. So this is 5 point something. I'm just going to estimate 5.1. Okay. Then we have 4.2. They just give that to us as the number itself. And then the last side length they tell us is the square root of 11. Okay, so again, let's go back to our perfect squares. 11 falls in between 9 and 16. So we would put the square root of 11 in between the square root of 9 and the square root of 16. So that means the square root of 11 is in between 3 and 4. It's going to be closer probably to 3 than to 4, since 11 is closer to 9 than it is to 16. So for the moment, I'm just going to estimate 3.2, because it really doesn't matter. Okay, so the square root of 11 is somewhere near 3.2, meaning if you take 3.2, you multiply by 3.2, you're going to get somewhere close to 11. So then I'm now going to try to order these. So the square root of 11 was my smallest number. So that needs to go with my smallest square. So the side length of square A then is going to be the square root of 11. Okay, then I have 4.2. So square B has a side length of 4.2. And then the biggest would be square C. That's going to have a side length of the square root of 26, which is about 5.1. Okay, so those are the side lengths of these three squares. Now we're going to ask ourselves, so given that information, now we have the side lengths, what are the area of these squares? Well, if we have the side length, we have all that we need. Because to find the area of a square, or of any rectangle, we just take that side length, and you multiply by the side length again, because it's like the base times the height. If this is the square root of 11, since it's a square, this is also the square root of 11. So the area of square A is 11, because that's the definition of a square root. You multiply the square root of 11 times the square root of 11, you get 11. Okay. Awesome. Okay, then let's go to C. Similarly, we have the square root of 26 times the square root of 26. What is that? The square root of 26 times the square root of 26? 26. Okay, and then finally for B, we'll just have to do that by hand. We have a side length of 4.2, another side length of 4.2, so the area is 4.2 times 4.2. Which is 17 and 64/100. Okay, and all of these side lengths, we're not told, we would say are just in units. And then the area is in square units, 2-dimensional. Okay, lastly, we're going to write the exact value of the side lengths in units of a square with the following areas. For the lengths that are not whole numbers, we find the two integers they are between. So, if we have a square that has an area of 16 units squared, the side length for that square is the square root of 16. So we're going to find the square root of 16. And that is the same concept for all of these. We have the square root of 100, the square root of 18, the square root of 9/16, the square root of 31, and the square root of 0.17. Some of these have nice, easy square roots for us. Some of these are perfect squares. And some, the exact value is just what I just wrote down. So let's do a few of these quickly. What's the square root of 16? Square root of 16 is 4. 4 times 4 is 16. What's the square root of 100? 10. 10 times 10 is 100. Okay, what is the square root of 18? The exact value is just the square root of 18. That is going to be in between 4 and 5, because the square root of 16 is 4 and the square root of 25 is 5. The square root of 9/16, that is tricky, but that does actually have an exact value. The square root of 9 is 3. The square root of 16 is 4. So 3/4 times 3/4 is 9/16. Thus, that is our answer there. And of course, 3/4 is in between 1 and 0. But that is a rational exact number. The square root of 31, that is the most simplified answer for the exact value. That is in between 5 and 6, because the square root of 25 is 5 and the square root of 36 is 6. And then finally, we have the square root of 17/100. That is the exact value. That's not a perfect square, and that's going to be in between 0 and 1. The square root of 0 is 0, and the square root of 1 is 1. So that is in between those. This can be challenging stuff because we're combining both new number sense work with understanding what a square root is and being able to find the square root of a number. And it involves some geometry, which if we forget that, then it can be challenging. But just do the best you can. Communicate if you need help. Great job making it through the video.